Today we're going to learn the chain rule for finding derivatives of functions. So go ahead and find each derivative in A, B, and C. Pause the video and do that. So you should get y prime is 2x plus 6. F prime of x is 50x. And this other y prime should be negative 8x plus 28. So double check with a neighbor if you didn't understand any of those. Now, that's what we've been doing before. What I would like to investigate now is what if I had written that original function a different way? So what if instead of writing x squared plus 6x plus 9 in that first example, what if I had written y equals x plus 3 squared? Same thing as our original function, but then how do we get back to this 2x plus 6? You may have some ideas. Okay, and then part B, what if I had written f of x equals 5x squared. If we multiply 5x times 5x, we still get 25x squared. So how would I get 50x? Does your pattern, what you saw in part A, still hold true? And then in part C, that would actually factor to y equals negative quantity 2x minus 7 squared. So if you multiply that out, multiply through by a negative, you get that original function. And how does that give us negative 8x plus 28? Well, there is something called the chain rule. So you may remember from advanced algebra and pre-calculus that there's something called a composite function. And a composite function is when we have a function inside another function. So on part A, we have x plus 3 on the inside of the function, and then that inside of the function is squared. So we have two different functions, one inside the other. Same with part B, 5x is the inside function, quantity squared, or x squared, is the outside function. And then in part C, the inside function is 2x minus 7, and then we kind of have two outside functions, the opposite of the function and then the function squared. You could think of that as negative x squared. So the chain rule basically allows us to take the derivative of composite functions, and it makes our lives a little easier. So let's talk about the pieces of this function, or this rule. So we have an original function that is a composite function. We have an outside function, which is g, and an inside function, which is h. So then the derivative of that composite function is the derivative of the outside function around the inside function times the derivative of the inside function. So let's write that. So that's the derivative of the outside function, g of x, around the inside function, times the derivative of that inside function. So let's take some derivatives using the chain rule. So in part A, my y prime is going to be the derivative of the outside function, and in this case, the outside function is just x squared. So to take the derivative of x squared, I would do 2 times my x, which in this case is a function, and then the power of 2 would become an invisible power of 1. And then my inside function remains the same. And then I would multiply that by the derivative of my inside function, x plus 3. But the derivative of x plus 3 is just 1. And if I multiply that out and simplify, I get 2x plus 6. And if you recall, that's what we got when we took that derivative originally. Okay, so let's look at part B. F prime of x. Again, I'm looking for my inside function and my outside function. So my outside function, again, is x squared. So I'm going to bring down my squared, leave my inside function as is, reduce my power by 1, so it's that invisible 1, and then take the derivative of my inside function, f of x, 5x, and the derivative of 5x is just 5. And if I multiply that out, I get 2 times 5 times 5, that's 50, and then I have my x multiplied on there, and that's what we got before. Okay, another one, y prime. I'm going to take the derivative of my outside function. So this time when I bring my 2 out front, it becomes a negative 2 because of that negative that was already there, times my inside function, and then reduce my power by 1. Okay, and then take the derivative of the inside function, 2x minus 7, is just 2. And when I multiply that out, negative 2 times 2 is negative 4, and multiplying through by a negative 4 gives me negative 8x and positive 28, just like we got before. So we've talked about the derivatives of sine of x and cosine of x before. See if you remember what each of those are, and if you don't remember, draw a little sketch, think about slope. Pause the video here if you need some time to think. And you should come up with sine of x, derivative is cosine of x, and cosine of x, derivative is negative sine of x. Hopefully everybody got that. Okay, so let's go ahead and do some more examples with slightly different twists on them. So in part A, we're going to find the derivative. This is a chain rule problem. It has a function inside of a function. So we're going to have f prime of x. Remember, we're looking for our outside function first. So what I see is something cubed. That's my outside function. So I'm going to bring my 3 out front, drop my 3 by 1 power, just like if I was doing the derivative of a plain old x cubed. So 3, my inside function remains the same, and then drop my power by 1 power. And then I'm going to do my derivative of my inside function. Derivative of x cubed is 3x squared. Derivative of 7 is nothing, just a 0. So then I have times 3x squared. And I can simplify that. So my f prime of x becomes 9x squared times x cubed plus 7 quantity squared. And you could multiply it out if you want, but we don't need to do that. So that would be my final answer. Okay, let's look at the next one. So here we have a sine of x. So I see my outside function is sine of x. My inside function is x to the 5th. So when I take my derivative, I'm going to have y prime equals the derivative of sine of x, which is cosine of x. Except it's not really cosine of x, it's cosine of whatever was inside, times the derivative of my inside function. And the derivative of my inside function is 5x to the 4th. This one is slightly trickier. We cannot multiply x to the 5th and 5x to the 4th because x to the 5th is inside cosine and 5x to the 4th is not. So I'm going to bring my 5x to the 4th out front. That's where it's going to make the most sense. And then I'm going to multiply by that cosine of x to the 5th. Okay, let's do another one. So this time, cosine to the 4th power of 2x is the exact same thing as cosine of 2x quantity 4th power. So that 4th power that was inside by the cosine really means you're doing the 4th power of all of cosine 2x. Okay, so when we take the derivative, our g prime of x is going to be the derivative of the outside function, which is now x to the 4th. So we're going to do our 4th power out front, and then we're going to do the inside function, which is cosine of 2x. And then we're going to drop that power down by 1, so now that's to the 3rd power. And then we're going to do the derivative of our inside function, which is cosine of 2x. And this actually is a double chain rule, because our inside function is also a composite function. So I'm going to do the derivative of cosine, which is negative sine, and have its inside function stay the same. But then I also have to do the derivative of the inside function of cosine of 2x. So I do the derivative of 2x. And that is 2. I have run out of room, but pretend like I'm multiplying by 2 out at the end there. Okay, so then I can simplify that. Let's see, so I have a 2 times a 4, so I have an 8 out front. I could move my negative from my sign out front as well, make that a negative 8. And then I have cosine cubed of 2x. Remember, I can move that 3 from the outside to the inside or the inside to the outside. It means the same thing. And then times sine of 2x. Okay, so tonight's homework, now to your book. Problems are online. I've taken pictures of the book and posted them online if you didn't bring your book. Work hard. We'll go over the quiz number 1 on Wednesday when I see you after the PSAT. You can still retake your test Wednesday if you are interested at ST time. And any questions, just email me. Good luck.